last section in here, we're only going to do part of it today. So we're going to look at the linear approximation piece. And it's really kind of stuff that we have already been looking at when we talk about these linear approximations. We know that if you have a curve, when you find the derivative, what does that tell you? Slope of the tangent line. Okay, so if this blue one's my curve, this pink one here is my tangent line. Well, if you have a point on this curve and you want to approximate it, so maybe you couldn't find it exactly. Now I realize we have calculators, so that's not really an issue, but there are some really nasty functions where that is not an option, and so you need an easier way to approximate it. So if we need a simplified version, the equation of a line is not complex at all. So if we could find the equation of this tangent line, then you could look at the point on the tangent line. Now, is it the exact same? No. Is it a good approximation for the point on the curve? Yes, to a point. You know, right back here, it's an extremely good approximation. Over here, probably not so much. So we can use the tangent line to approximate points on our curve. When we do this, it's called a linearization. So if you write, your book gives you the equation like this. I think that's probably a little more complex than it needs to be. If we just think a linearization, L of x is for linearization, that's like your y. So it's just y equals mx plus b. Okay, just the equation of a line. We know that slope is from the derivative. So if we can write the equation of the tangent line, we can plug in the x values and get an approximate for the y values. Let's look at one. So if I wanted to find the linearization of f of x equals the square root of x plus 3 at a equals 1 and use it to approximate a couple of square roots. So this is like, your book usually calls it an a, it's an x value. Okay, so that's like at this point, if my x is 1, can you tell me what the y value is at that point? 2. If you put it into the equation, you get the square root of 4, which is 2. So typically when we're doing a linear approximation, we want an a that we can plug into our ugly function and get a nice answer out. So then if I want the linearization, I need this equation for the tangent line. To write the equation of a line, we need a point and a slope. We have the point. How do we get the slope? Derivative. Okay, so we know our function. The square root is the same as a 1/2 power. So our derivative, 1/2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, which is just 1. Okay, if you want to rewrite this, this would be the same as 1 over 2 times the square root of x plus 3. So what we need is the derivative when my x value is what? 1. So if we put a 1 into this equation, we get 1/4. That is our slope. So now we have a point, we have a slope. How do we write our equation? Y equals mx plus b. So y equals m times x plus b. Is like 8 over 4 minus 1 over 4 is 7 over 4. So typically instead of y, we're going to put L of x just to show it's a linearization. So our linearization is 1/4 x plus 7/4. So that's the tangent line. And that would be a good approximation as long as x is close to what number? 1. So as long as x is close to 1, this is good. But if our x is too far from 1, this is probably not going to be a great approximation. Okay, then I want to use this to approximate a couple square roots. So the square root of 3.98. What is my x if I'm doing the square root of 3.98? Remember, the equation is the square root of x plus 3. So what would x have to be? 0.98. So we put 0.98 into our equation. All right, so is there any way you could have done the square root of 3.98 without picking up a calculator? Josh can. You could maybe get a close approximation, but you could not find it exactly without your calculator. Now, could you work this out without a calculator? Yes, you can. It's not nice, but could we? Do you have the math skills to do this?
No.
You can multiply and add. Come on. It's going to be a decimal. We can handle that. You guys are making me want to make you do this by hand. What? It's not that hard. I mean, if we did like 0.98. Yep, times 1/4, or you could divide that by 4, so we would. You forgot how to do this?
No. Yeah, I don't know.
Guys!
No.
Come
There's no
on!
connection.
18 divided by 4. 16, so 2, you bring down a 0. So that's 0.245 plus 7/4 is the same as 1.75.
You know what's easier than that?
Couldn't we
Letting
just
us use a calculator.
What?
could we have done 0.25 times 0.99?
Yeah.
No.
Yeah, absolutely.
So it's like 1.
So we get 1.995.
Oh, that was cool.
Yeah.
Check me on your calculator if you don't believe me. So 1/4 times
Yeah.
0.98 plus 7/4.
I believe you, I just don't think I'll do it. I think I would submit an empty test if we had to do it by.
Oh, you could do this, guys.
We just need a extra password. We'll go into chemistry time.
The other one I asked you to approximate was what? Okay, so what's our x in that one? So we would be doing the linear approximation of 1.05. So 1/4 times 1.05 plus 7/4. Make you guys do this.
You're gonna wait my
I'm really.
0.0125.
Oh, how'd you do that so
I
fast?
did in my head.
Uh huh. Uh huh. Do we need a review on like multiplying and dividing with decimals?
I do it in my I think you're really proud. You should be.
Huh?
I think you're so proud of us.
I am something right now. Remember if you multiply these, so 5 times 5 is 25. 0 times 5 is 0, plus 2 is 2. 5 times 1 is 5. And then what do we put next?
That's 0.
A 0. 2 times 5 is 5. Or it is not 5. 10. So we would put the 0, carry the 1. 2 times 0 is 0, plus 1 is 1. Times How many decimals do we need?
Wait.
4. You have 4 decimal places in your problem, so you put them all together. So we would have this plus the 1.75. You just did it in your head? Okay. Ashamed of you guys. Come on. Okay, so
Maybe this one was an argument already.
we could not have done the square root in our head, but we could do the decimals when we're just plugging them into the equation of a line. Okay, so although you may not want to, the linear approximation allows you to find those values without the calculator. Now, I want to know if these are overestimates or underestimates. So let's think for a second. What does a square root look like? Yeah. If you put in a -3, you get square root of 0, which is 0. If you put in -2, you get square root of 1, which is 1. If you put in a 1, you would get square root of 4, which is 2. So it just looks like this. So if you drew that tangent line, would it be above or below this graph? Above. So what that means is our approximations are higher than the actual values. So these are over approximations, or over estimates. Okay, if your tangent line was below your graph, it would be an underestimate. The next slide, which you might have been referencing when I asked you to find these, has a bunch of these values, and it just shows you the difference. Here is the linear approximation. This is the actual. So we can see they are very close. What happens as we get further away, like when I do the square root of 5 or the square root of 6, what's happening? There's a bigger difference between the actual and the approximation. So when our x value gets further than 1, the estimate is further from the actual value. All right. I want you guys to try example 2. It's very similar. You're finding a linear approximation. It's again a square root function. Your a is 0 this time. So what's the point on our graph? X is 0. To get the y value, you plug it into the equation. So you get the square root of 1, which is 1. All right. To get the slope, we need the derivative. So this is like 1 plus x to the 1/2 power, so 1/2 comes down, inside stays the same, subtract 1 from the power times derivative of the inside. So now what do we do? So we get 1/2. So this is the slope. So now we have a point and a slope. So we can write the equation of the line. Y equals mx plus b. So our linear approximation is I didn't ask you to actually estimate any here. If I did, you would just be plugging the x's into this equation. So I just asked for the equation itself. All right, any questions on that one? Let's try some more with some different functions. If I want the linear approximation on both of these, we're going to do where a is close to 0. So, for the first one, if my a is 0, What do we get when we plug that in? 1. It's 1 over 1. Alright, now we need the derivative. Keep in mind, this is the same thing as saying 1 minus x to the negative 1 power. So the derivative, exponent comes down, the inside stays the same. Subtract 1 from the power times derivative of the inside, which is negative 1. Gives me a 1 over 1 minus x squared. Is everybody okay with how I got that? So now we plug in our a value, which was 0. And we get 1. That's my slope. So point, slope, write your equation. So linearization is 1x or just x plus 1. That one you could definitely do without a calculator. Okay, you guys try B. Sorry, I didn't leave you much space on that slide. We plug in 0. We get 1 minus 0, which is 1. 1 to the power is still 1. We need the derivative. So exponent comes down. Inside stays the same. Subtract 1 from the power times derivative of the inside. So 3 halves times a negative 2 is negative 3. This time, this exponent is positive. So all the others, we moved it to the denominator because it was a negative exponent. This is positive, so it just stays up top. So then f prime of 0, if you put in 0 for your x, you get negative 3. So that is the slope. So we have a point, we have a slope. So our linear approximation is negative 3x plus 1. Is that okay? We're going to do 2 more problems. These I'm kind of switching it up a little bit. I want you to use linear approximation to find what 122 to the 2/3 power is. Alright, so how is this different than the previous problems? Yeah, I didn't give you an a, I didn't give you a function. So we can find those. Right, our function, if I change that 122 to an x, my function would just be x to the 2/3. Okay, think about what a 2/3 power means. It's saying you have to do the cube root of this number and then square that. And this problem's ugly because is 122 a perfect cube? No. Our a value needs to be close to 122, but it needs to be one that we could work this problem out. So it needs to be a perfect cube so that we can work it out. So a perfect cube is like 2 to the 3rd power is 8, 3 to the 3rd is 4 to the 3rd, 5 to the 3rd, 125. So that's going to be the best value for us. So our point, if we put in 125, the cube root of 125 is 5, and 5 to the 2nd is 25. So there's our point. So now we do our derivative. exponent comes down, subtract 1. Okay, you can leave it like this, but if it's easier for you, we know a 1/3 power means a cube root. Because the exponent's negative, it would be on the bottom. So we have to think about, what if we put in a 125? What is the cube root of 125? And 5 times 3? 15. This is the slope. So we have our point and slope. So we need our equation. So we plug in the y equals mx plus b. Alright, probably not going to be beautiful. We can work this out. So this would be 250 over 15 if we divide by 5. Okay. 25 is like 75 over 3 minus 50 over 3 would be 25 over 3. So a linear approximation is 2 over 15x plus 25 over 3. Am I done? What did I need to approximate?
122.
Alright, go ahead and put this in your calculator. Tell me what you get. 2 over 15 times 122 plus 25 over 3. So that is our best guess.
Why did I put 122 in instead of 3? Because it's 3.
Oh, because the other equation, it was like an x plus 3, not just a square root of x. So because our function itself was just x to a power, we didn't have to adjust it. Alright, see how close we are. Type in, what is 122 to the 2/3 power? We're close? Yeah, we're off. It was 0.598 and we said 0.6, so pretty close. Alright, last one. I want to estimate the cube root of 25. So what would be my function? Cube root of x or x to the 1/3. Okay, what is our a value going to be? What's something we can do the cube root of that's close to 25? Yeah, 3 to the 3rd is 27. So we could put in a 27, and if you plug that in, the cube root of 27 is 3. So we have a point. Derivative. If you want to rewrite it, a negative exponent puts it on the bottom. Then to get our slope, what value do we put in? 27, our a value. Cube root of 27 is 3. 3 squared is 9 times 3, 27. there's our slope. So y equals n times x plus b. So we have a linear approximation, and then what do we need to do to answer the question? And what does that give us? Check the cube root of 25. Are we close? You could just do 2 to the 1/3 power, or if you go into the math menu, there's a cube root function. All right, so we are stopping there. You are ready for the day 1 problem, so you've got 5 of them, and then we will finish with section